In this episode, we will talk about the neutrino oscillation, or equivalently, the neutrino mass problem. Let's enjoy it. First of all, let's analyze what is a neutrino. Neutrinos are particles with a very tiny mass. They are fermions with a spin 1/2. In fact, they obey the Dirac equation. In addition, they have zero electric charge, or in other words, they are neutral particles. The neutrino as a particle was postulated by Wolfgang Pauli in 1930 in order to keep the conservation of energy, momentum, and angular momentum during the beta decay processes. In other words, without the neutrino, these conservation laws would be certainly violated. In order to analyze this aspect in a better way, let's take a look at this animation, where the neutron in a free state decays into proton, electron, and antineutrino. Without the existence of the neutrinos, the violation of the fundamental laws just mentioned would be certainly possible. Given the fact that the neutron, as well as the proton, is a baryon containing 3 quarks, the transformation of the neutron into proton is equivalent to the exchange of the quark up by a quark down inside the neutron. In this way, then, the residual products are the other particles, including the electron and the neutrino. The neutrino appears in the electro theory as a massless particle. The reason for this unfortunate statement is that by the time when Weinberg, Saline, and Glasgow developed the electro theory, it was believed that the neutrino was massless. Then in the Lagrangian of the electro theory, the neutrino doesn't get mass via the Higgs mechanism. In fact, the Higgs mechanism only gives mass to the bosons C and W and other elementary particles. The neutrino then was kept as a massless particle, and this has become a modern physics problem. However, it came out that the neutrino is massive. This has been a big surprise for the international scientific community because the standard model of particle physics seems not to accommodate the possibility for the neutrino to have mass, given the fact that the neutrino doesn't get the mass via Higgs mechanism. The existence of the neutrino mass is tied to the fact that the neutrino oscillates when it moves through the space-time. This means that a neutrino, which is emitted as an electronic neutrino, is transformed to tauonic and muonic as it propagates through the space-time. This process is cyclic and it repeats several times until the neutrino reaches a final detector. The neutrino oscillation was the reason for the existence of the famous solar neutrino problem, which consists on the fact that only electronic neutrinos are emitted by the sun. Then the scientists did theoretical calculations based on the luminosity, and they expected certain amounts of neutrinos when they arrived to the Earth. Unfortunately, by then, the amount of neutrinos detected, electronic neutrinos, were much lower than what it was expected. It came out to be clear after that the reason for this discrepancy is the neutrino oscillation. But then why do the neutrinos oscillate? The reason for the neutrino oscillation comes from the fact that when the neutrino moves through the space-time, it appears in a well-defined quantum state, in a well-defined eigenvalue of mass state, namely M1, M2, or M3. Each one of the eigenvalues of mass is a linear combination of the mass of the different flavors. Then the neutrino is in reality a mix of quantum states. In summary, the neutrino is a massive particle with a tiny value of mass. The Higgs mechanism then cannot give mass to the neutrino inside the standard model of particle physics. Finally, the neutrino, when it's generated, It appears in a well-defined quantum state with a well-defined eigenvalue of mass, which is a linear combination of the values of mass for the three different flavors. This is what generates the quantum effect of neutrino oscillations. The neutrino then changes from one flavor toward another when it moves through the space-time. If you liked this video, please give us a like, share the link and subscribe to the channel. More videos in Spanish and in English are coming very soon. Continue with us.